Okay, looking at assignment 1, working with graphs. And in this assignment, we're mostly just reading and interpreting it and answering questions about the graphs. Looking at the main types that we introduced yesterday. Thank you. Which were, circle graphs or pie charts, histograms, bar graphs, and line graphs. So number 1, they do a survey. What's a survey? Kind of, not exactly. Surveys just you go around and ask people stuff, and they give you answers. Quite often, surveys are usually like categorized, like you can only pick certain options, right? Telephone surveys are really common, and then they publish data and they turn it into graphs so that we can see what the numbers tell us, right? So a survey found that these are people's favorite type of movies. And overwhelmingly, people prefer what kind of movie?
Comedy and
comedy
and family.
And family movies. So positive stuff, right? And then there's smaller amounts that like these other things. Okay.
The most smallest one is mystery.
Yeah, mystery, adventure. Those are hard movies to do. Mystery movies. Okay. All right. What is this graph about? Well, usually you can tell it from the title, but what would you say?
Favorite types of movies.
Yeah. Favorite movie types. Which movie type is the most popular?
Fancy.
Comedy at 32%. Thank you.
Yeah, lift up.
Yeah, this thing's down too far. There we go. Better? I don't know who's using this thing. That's easier. Okay. See, if 240 people were surveyed, how many chose horror as their favorite type of movie? So what percentage? 11%. So you just go 11% times the 240 people, right? And what decimal is 11%? 0.11 times 240. How much? 26.4. Now, because you're talking about people, you can't really have 26.4 people. It's going to have to be what's called an integer, like a counting number. So I'd probably round that down, right? Say approximately 26 people. Okay. Chose horror. I'd be one of those. I love horror movies. Especially bad ones. Love bad ones. They're always entertaining. Yeah, just like movies that they didn't make it very well.
Oh, okay. Like the blood splatters on there.
Yeah, I like them all. I could give you a list of 100 great horror films off the top of my head. Okay, I don't know why I like them, but I like them.
Like that cheap film called the Ginger Film, like a gingerbread film.
Oh, really? Oh, I totally got to see that. Okay. So D, a total of 36 out of the 240 people surveyed said they liked one type of movie. So let's go 36 divided by 240. If I'm turning that into a percentage, I'll just multiply by 100%. So 36 divided by 240 times 100. And I got 15%. Does that match anything in the chart? Which one? Yeah, it's up there, action. So action.
I think a lot of people would like action more.
Yeah, remember this survey is based on those particular 240 people. So if the survey was designed to be representative of the entire Canadian public, and this is what statisticians do, there's people that work for Statistics Canada, this is their job. And they might, there's certain calculations that, based on what you're trying to find, you have to survey a certain amount of people. 240 people would not be enough to represent all of Canada. Okay, maybe you'd have to do 2,000 people or something. There's actually calculations based on how many you need to do to make your data what's called statistically significant. And there's different rules about how you, about where you collect the data from, who you ask, right? And if it was for all of Canada, you'd have to sort of do surveys, you'd have to survey people in different regions. You couldn't just survey people in Winnipeg, because otherwise your data would be biased towards people from Winnipeg, right? So you can't say, what people like in Winnipeg may not necessarily be exactly the same in Vancouver, so you wouldn't just survey people in Winnipeg. Does that make sense? Yeah. And there's lots of, it's quite interesting actually, the whole field of statistics on how you do surveys, how they're designed, those kinds of things. But this is just 240 people. We don't know anything about those people, right? Like, if these 240 people came from a small town, and the people in that town were very religious, we would expect that would, what we call that skewing the data. It probably wouldn't be the same as doing it like downtown Winnipeg, right? It might be different because there might be sort of like it's like culturally different, okay? But then also, if these 240 people were from like a remote area of Canada, they may not have the same access to movies that people would in the city, which would also skew the data, right? If they're not able to choose from as many different things, if they can only watch, for example, regular television, which, regular television stays away from these things like horror, right? Because usually in horror, like, you can't let kids watch a lot of that stuff, and usually bad language and stuff, so primetime television isn't allowed to show that stuff unless they severely edit it, in which case it's not very fun to watch. So it's you don't usually see too many horror movies shown on regular television at 7 o'clock at night, right? What do you see more of? Comedies, family movies, right? Safer for TV kind of stuff. But that's changing now, right? A lot of people are getting different kinds of packages, subscription things. Yeah. All right. And the whole horror genre is becoming more popular because of the success of some certain TV series.
Yeah, but
right.
There's never new horror films anymore because they remake the old ones.
Sometimes, but then there are some new directors that Jordan Peele, that new movie of his, Us, is supposed to be really, really good, and it's inventive, it's different. His last movie, Get Out, was very. Anybody see Get Out? Yeah, it's messed up. It was very, and it was unique. It was unique. Yeah.
I don't watch horror films.
No. Yeah, just now, Us is supposed to be really good. These people are like, this family is vacationing at a cottage, and they look out and they see this other family standing there. And like, as they get closer, it's basically like them, but kind of distorted in that scary kind of way. Yeah. Then I guess I don't know. I guess they have to fight themselves to survive. I'm not sure.
Yeah.
I want to check the last one.
You watched the last one?
No, I want to watch the last one.
Oh, Glass. Yeah, M. Night Shyamalan. Yeah. Okay. 2. The following graph shows the population of Creighton, Saskatchewan, starting in 1991. Does anybody know where Creighton, Saskatchewan is? No? Saskatchewan's got lots of towns. And this one want another one? Oh, the book. Yeah, you need the book. Yeah, yeah. So Creighton's big enough, I guess they would call it a city, because look at the numbers here. In 1991, there were, looks like about 175,000 people there. So we'd call that a city. A, part of the graph that shows when the population was increasing. So where was the population going up? So from 1991 to 96, it went down. But then it started going up from 96, well, I guess from 96 all the way to 2016. So I don't have a highlighter, so I'm just going to circle that. That's increasing. So, and I could also say from 1996 to 2011, the population was increasing. Increased. Okay, so determine the years when the population was going down. Well, that would just be, right? 91 to 96. Just go like that. 1991 to 1996. Determine the population in 2006. I'm looking inside the graph. What's that called again? Interpolation, yeah. So in 2006, I guess technically there's a point there which makes it easier. So you don't have to interpolate as much. If it was 2007, we'd have to sort of estimate, right? This one, if you went up there, I'm not sure. It's not quite 182,000. It's over 180,000. So 181 would be halfway, but it looks like it's a little higher than halfway, right? So I would just go like 181,000. I'm just going to add a random number, 500 after that.
That would be around halfway.
Yeah, so I'd say approximately. Yeah, you could have put anything. As long as you put over 181,000, it would have been okay, right? Because there's no way to get more accurate than that. Based on current trends, predict the population of Creighton in 2016. So I have to extend the graph. What's that called? Extrapolation, right? So I'm just going to go up here and use a straight edge and make sure it goes past 2016. And at 2016, I'm just going to sort of work my way up and make a point there. Let's say that's around 2016. And if I went across here, again, it looks like it's a little more than halfway between 182,000 and 184,000. So, yeah, approximately 183,000 would be in the ballpark. Yeah, does that make sense? Okay. Okay, number 3. The following graph representing Winnipeg's high school graduation rate is from the 2015 PEG report on health equity. Why would there be health data on graduation? Why would health agencies be interested in graduation rates? Why would public health people, analysts, be interested in collecting data on high school graduation rates? What's that? But in general, why would health people that are concerned about the health of Canada be collecting data about graduation? That one would make sense, right? Yeah.
They get stressed out because they're waiting for where they're gonna get in.
Maybe. But, so there's other things that are related to it, right? So here's a different question for you. Would you say that someone who has a higher level of education is more likely to be healthy, or is likely to be healthier than someone that has a low level of education? Maybe? Yeah. So there are health indicators there's health indicators, and that's worldwide, that the lower the level of formal education of people, the lower the quality of health. So the higher the level of education people achieve, the better their health indicators, right? And some of it makes sense, right? So if you think about it, the more education you get, the more you know, the better you're going to be able to make decisions and to learn new things, right? But also, the more education you get, the more likely you are to get like decent paying jobs. If you get decent paying jobs, you're more capable of eating better, right? Choosing better foods, right? I remember when I was a university student living on my own, my diet was really bad, right? And it wasn't because I was deliberately eating bad, it's because I didn't have the money.
So when you were eating no name Mr. Noodles?
Yeah, no name Mr. Noodles, yeah.
Oh, okay.
Don't even show those to me.
The last day of school for Mr. Noodles.
Yeah, at one point I was on a $7 a week food budget. That's hard. I wasn't very healthy. I was slim, but not just because I couldn't eat. So that's why they health, like people that study health, we call them analysts. They analyze health data. They'll take things about education, right? Education is good for people, physically good for people, right? So they'll track things like that. So 6-year high school completion rate, they know that like the fastest you're going to complete high school is 4 years, right? Regular high school. But for a lot of students, they use a 6-year window. Some need to finish up some courses, some had to go work for a while, like it's, that kind of stuff. So which academic year had the highest graduation rate? Let's go look for the highest point. Where is it? Yeah, 2008, 2009. So what was the graduation rate in 2010, 2011?
85%?
Yeah, between 84 and 85. It's closer to 84, so you could say like just over. Rather than making up a number, I could say just a bit more than, just over 84%. That's pretty good, right? If over 80% of students are graduating within the 6-year window, that's pretty good. What's the difference in graduation rates for the years 2001 to 2002 and 2011, 2012? So the difference in mathematics, what do you do when you're finding a difference? What mathematical operation? Takeaway, yeah. Difference means subtract. If I see the word difference, I put a little symbol there to let me know I'm going to have to subtract something. Okay, so in 2011, 2012, my graduation rate was around 84, right? In 2001, 2002, it was more like 80 and a half. So if I subtract those, 84 subtract 80.5, I'm going to get about 3.5%. So it's gone up about 3.5%, which is pretty significant if you think of how many students there probably are in Winnipeg. How many high school students do you think are in Winnipeg? No idea. How many high schools are there? Yeah, the average high school probably averages around 1,000 students. Some are smaller, some are bigger. So, I don't know. Do we have 15 high schools? Yeah, 20? So let's say 20,000 students. If you take 20,000, you multiply by 3.5%. That means like an extra 700 students managed to graduate versus 2001. Okay. D, describe the trend in graduation rates from 2004 to 2006. So 2004 is here, so I'm looking there. And 2006 is there. So what happened here? It looks like it went up. So increased
500.
by, yeah, looks like it by about 1%, right? 1%-ish. Yeah, ish. Ish. We can't be exact with these graphs, so it's okay to say about, approximately, or my favorite, ish. I don't even know where that came from. It's slang. It's slang. That's a good response to things. If you don't want to be very, very resolute, if someone says, "You feel good," you can say "ish." Okay. Okay. Number 4. The following is the average temperature graph for Beaver Lodge, Alberta, Canada.
With very small points.
Yeah, hard to read. What's the average temperature for August? So let's go look at August. So January, February, March, April, May, June, July. August is this one. And if you go up there, it looks like it's around not quite 15 degrees. Say around 13 degrees. 13 degrees. This is Celsius. That's not very warm.
No, it's not.
13 degrees, man, that's not super warm. It must be pretty, I don't know, is that super northern Alberta, I guess? What's the average temperature for mid-September? 10, around 10 degrees. That one's right on it's right on the line there, so it's like, you could just say 10. Predict the average temperature for next February. So we would assume that next February is the same as this February. So it looks like it's -10. And that's an average, which means some days will be warmer, some days are going to be colder. But when you add up all the numbers for the month, that's what happens, right? Winnipeg's is, if you look at a Winnipeg average temperature bar graph, it looks a little bit more exaggerated than this because Winnipeg gets very, very cold and very hot.
Average temperature in August is 32.
Yeah, it's probably high 20s or something, yeah. So probably the average would be like more from like -25 up to +25. So it's a little more exaggerated. We have a bigger swing in temperatures. Some places the temperature stays the same most of the year, and the only thing that changes is precipitation. There's a wetter part of the year and a drier part of the year. Yeah, it's interesting. Okay. Number 5. This one's hard to read. Basically, this graph's too small. So the darker bars represent the years from 2007 to 2011, and the lighter bars represent the years 2002 to 2006. It's hard to look at, okay? So, A, for the years 2002 to 2006, which area in Winnipeg had the least number of heart attacks per 1,000 residents aged 40 and up? I should pay attention to this because I'm over 40 now, so I should move to that area. Where's the lowest area?
There's a couple there.
There's a couple?
Probably St. Boniface.
Let's see here. River Heights. That's where I live. That's not bad. It's one of the lower ones. Oh, no, we're looking at the, we're looking at 2002 to 2006, so it's the lighter bar, the top bar.
St. Boniface and River Heights.
St. Boniface. Okay, St. Boniface looks like a little bit better. Just slightly better. So I would say St. Boniface. But it's not so much better that I'm going to move from where I live to St. Boniface. Estimate the number of heart attacks per 1,000 residents aged 40 plus in Winnipeg for 2007 to 2011. Okay. Well, that's hard. It didn't say which area. It says all of Winnipeg. So that means I'm going to have to add up, or total, add up all areas. That's going to be a little tedious here. So we're looking at the dark bars. This first one here, I'm just going to put the number past it. It looks like around 3, right? I'm going to put a 3 there. Fort Garry's just over 3. Transcona's almost 4. St. Boniface is almost 3. St. Vital, I don't know, let's call that 3.5. Seven Oaks, let's just call it 4. St. James Assiniboine, I'll call that 3.5. Inkster, we'll call that 5. River East, 4. River Heights, 3.5. Point Douglas, almost 6. Downtown, I don't know, call it 4.5. And oh, wait a second. Why is there a Winnipeg?
It's Winnipeg. It's Winnipeg.
Oh, I see what they did. They didn't make it that clear in the graph. So this one here is the this one's the average for all areas. Average for all areas. And then this one's broken up by area. Okay, so this question didn't have to be. I didn't have to add all those up, I don't think. Could have just looked at that, right? Let's go look at the answer key. It's not very clear in the question. Assignment 2, number 5. Assignment 1, sorry, number 5. Yeah, okay, so that's the average for they've already averaged it. Okay. So I didn't need to add all those up. That was a waste of time. The question was easier than I thought. I could have just looked at this one. It's just under 4, so I don't know. Don't add up all areas. We have the average at the top. So just under 4. Whatever you want to call that, just under 4. C, describe the trend when comparing the data between 2002, 2006, and 2007, 2011. Okay, so looking at this whole chart all together, what do you notice when you compare the light bars to the dark bars? It looks like for most of these pairs, the dark bar has gone down a little bit, with the exception of downtown. So if I was looking at that, I would say it looks like the number of heart attacks has gone down a little bit. A little bit. I would say that this one is slightly lower number. And that's confirmed when you look at the Winnipeg average at the top there. See the dark bar is a little bit shorter? Not a lot, but a little bit. That means the number of heart attacks went down in 2007 to 2011. And D, which 2 neighborhoods had the most significant decrease, so that's down, okay, arrow down, in the number of heart attacks from 2002, the first time period, to the second time period. So go look for where the change between the first bar and the second bar is the most dramatic. Looking at it, Seven Oaks looks pretty significant. And Transcona, yeah. Now, anybody that knows the city really well, any idea why that might be? Yeah, Seven Oaks has a hospital, but that doesn't mean that influences how many people have heart attacks, right?
Less people go there, so nowadays.
Yeah. Does anybody know what's happened in the areas of Transcona and Seven Oaks over the last 15 years?
People go missing. They don't care about the patients.
This is the heart attacks have gone down. The rate of heart attacks has gone down. That's a good thing. Rate of heart attacks has gone down.
Oh, you're talking about heart attacks. I thought you meant the actual.
No. Any idea what's happened in those 2 areas, in particular in Winnipeg, in the last 15 years? No? So those 2 areas have had massive development with new housing and expensive housing. that. Housing development in those two areas significantly. Lots of new builds, lots of new builds, lots of new areas there. So who can afford to buy big new houses?
People with jobs.
People with pretty good jobs. And if people have pretty good jobs, what can you say about usually say about their education level? Usually a higher education level. And people with higher education levels, what can you usually say about their health?
Great health.
It's usually better. So both of those areas saw an increase in the number of people moving to those areas that had more money and likely more education, which means that the health of the area improved. Yeah. And that's why, if you look at people's incomes, like how much money they make, and you look at health, usually the higher the income, the better the health. That's why they keep those kinds of stats. Not for everybody, but on average, right? Yeah. And again, part of it's money, being able to buy better food, but also the more you learn, the more you want to learn, right? The more interested you become in like looking at diet and food, reading magazines and those kinds of things, making better decisions. Part of it's getting older. There was a time in my life I was happy if I just had pizza pops. If I just ate pizza pops. Those are not healthy for you. You shouldn't eat those very often. What's that? Homemade pizza pops, yeah. You know, it's a Winnipeg food, right? Pizza pops? Yeah. They were designed here, made here. So other parts of the world, didn't even know what they are. Whereas you grew up in Winnipeg, you're like, that's like a standard food that everybody eats, right? Okay, number 7. The Winnipeg Adult Education Center Student Council. Do we have a student council?
Yes.
Cool. Asks.
Yeah.
Wait, this is live. I mean, yes, we have a student council. I should probably know that. Asked 634 students to state their favorite pizza topping. The graph below shows the results. Hard to see on the overhead. 50% like pepperoni, 10% like supreme, whatever that is, 15% like sausage and
Supreme, wouldn't that be like deluxe?
yeah, probably deluxe or something, and 25% like I guess just cheese. I mean, most pizza has cheese. A, what percent of students chose sausage as their favorite topping? So that's 15% from the chart. B, how many students chose cheese? 25%. That's such a kid thing. Young kids, they just want cheese pizza. It's like, really? Put something on the cheese. No, they just want cheese. C, how many students chose pepperoni or? Whenever you see or, usually that means you're going to have to add your numbers together. So the word or converted to math usually means plus. Okay. How many students chose pepperoni? Well, there was 50%. And how many students were asked about it? 634. So 50% times 634
Times or plus?
times.
Or is that-
Percents are always times. So 50% of 634 is going to be multiply that by 0.50. And because I can do that one in my head, it's 317. Good. What's that?
How about me? How many students?
Yeah, how many students chose pepperoni? So 317 chose pepperoni. And how many chose supreme? So that's 10% times 634, which is basically 63 students. So if you add those two numbers together, I guess you get about 380 students?
No, my question is, you say 25%,
25.
but it says how many? What percent?
Oh, how many? Sorry, yeah, B says how many students? 25% times 634 equals, I can do this one in my head, 159? Is that right? Yes?
Yeah.
Yeah? How did I do that in my head? Because 25% is half of 50, and I already knew what half was here, so I just cut that in half again. It wasn't easy to cut in half, but it was doable. And I knew you would be rounding as well, because half of 317 is 158.5, and I knew you'd have to round up, so 159.
So we can do that, right? 25 times 674.
Yep.
Divide 100.
Yeah. 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 That'll work, right? So some people will just punch in 0.25 times 634, and other ones will do 25 times 634 divided by 100. They're both the same thing, so yeah, you got it. Yeah. Okay, number 8. The line graph below shows the speed of a car as it accelerates over time. Looking at the graph, what unit is time measured in? So at the bottom here, time, and it's got brackets and an S. What do you think S stands for? No, time is measured in. S is for seconds.
Is it milliseconds here? It says speed, bracket.
Yeah, time could have been in milliseconds, but it said S, so it's just seconds.
Oh.
So what unit speed measured in? Yeah, that's, so it says m/s. Anybody know what that means? No, milliseconds would just be ms with no slash. That's actually meters per second, yeah. C, what was the speed of the car at 4 seconds? So we go over to 4, we look up. This one's on a grid, it helps us. It looks like there's 5 lines here, so that's 10.2468. So it goes up by 0.2, making that, oh, sorry, that's 10, 12, 14, 16, 18, 20. So that'd be 18? Yeah, I think it'd be 18. 18 meters per second. If each of those little grid lines is worth 2, because there's 5 lines, right? 12, 14, 16, yeah, that works. D, what was the speed of the car at 3.5 seconds? So 3.5 would be right there. We're interpolating. We're going across. It looks like we're kind of halfway between vertically as well. So what's halfway between 10 and 20? Yeah, I'd say about 15 meters per second. And E, what do you think the speed of the car will be at 10 seconds? So that's going to be an extrapolation question. Unfortunately, there's not enough blank space here to not make a huge mess of this page. But the first thing I'm going to do, since I have a nice grid, I'd like to try to do a good job and get a good answer on this one. Which is made much easier with a proper ruler. Does anybody have a proper ruler? As far be it from me, as a math teacher, to actually have one.
Is this color, or do you want the small one?
We'll get a small clear one, that's even better.
Yes, this one.
Oh, wow, that's awesome. These came in your agendas. Anybody get a student agenda? These are good. Thank you. So, if I want to extend this nicely, looking at it, it looks like how many lines there? 1, 2, 3, 4, 5, 6, 7. Around 8 of these millimeters here makes up one of those little blocks. So I'm just going to count over to make the next one, and then I'll count again to make the next one. What's that? 6, 7, 8, 9. I need to do one more. Okay. Pretty hard to do this sort of freehand with something like this, so I'm going to call that 10 seconds there. Good. And this one, I'm going to use a ruler to extend it straight over there somewhere. And then I'm going to go straight up from there to see where it hits. Okay. And I'm half done there. Now I also need to see how high that is, which is also a pain in the butt, because I'm going to have to extend this all the way up, which is not ideal. So there, there, there. Have I got high enough yet? So maybe there. So that was 40. That's 50, 60, 70, 80, 90, around 100? 100 meters per second? What influences this number? Now, is it possible to get to that? Do you think it's possible for that car to even get that fast?
10 seconds.
100 meters in a second? That's like 100 meters is over 300 feet every second. Depends. Depends on whether like it can actually go that fast.
It's a jet powered car.
Depends on how much friction there is, right? Depends on whether the tires explode. Depends on how much wind, like the wind resistance, right? There's a lot of factors there. I mean, that's pretty fast. We don't know. We don't know if it's possible. Okay, and F, at what time did the car reach a speed of 10 meters per second? So that was here, and it sort of reached it around there, which was around 2.6 seconds. Okay. Okay, that's as far as we can get today. Some of these take longer, especially if you have to start drawing and measuring. Some of them you can just read them and do them. Okay, did everybody turn in their assessment thing?